This is the example video for the lesson on the midpoint and distance formulas. For number 1, we have to find the distance between 1, negative 1 and 4, 3. To do this, let's call this first point 1 and the second one 2. So that means this is x1, this is x2, this is y1, this is y2. To find the distance, I take x2 minus x1, and I square it. I'm going to take the square root. And I also have to take the same thing with the y's, y2 minus y1. It's worth note here that if you switched y2 and y1, if I called this first point, point 2, and the second one, point 1, I would just end up getting a negative inside, maybe. Even if I do get a negative inside this way, when you square it, positive or negative, it doesn't matter. You get a positive out. So this is my distance. That is going to be the square roots of, well, x2 minus x1 is 4 minus 1, or 3 squared. And now I've got y2 minus y1. 3 minus a negative 1 is 3 plus 1, or 4 squared. And that is 5. For number 2, we have to find the midpoint of the line segment with endpoints at -1, 2, and 1, -2. Well, to do this, let's take the average of the x's and then take the average of the y's. So, the average of the x's is -1 plus 1 over 2. The average of the y's is -2 plus 2 over 2. Now again, this doesn't matter what order I go in. I could add y1 plus y2, or I could do y2 plus y1. It's the same thing. And this turns out to be 0, 0. For number 3, we have to determine which point is closest to the point -1, 2. To do this, we could find the distance, which is the square root of the changes in x's and the changes in y's. Or, instead of doing that, we could find d squared, which is just the change in x's squared plus the changes in y's squared. The reason why it might be better to do this is because you're spending an extra step doing something you don't really have to do. Whether you square it or not, a number is going to be bigger than another. We can look more into that afterwards. So let's look at the first one. We have 0, -1. So my changes in x is going to be from -1 to 0, that's a change of 1. And I'm going to square that and add it with the changes in y's. The change between 2 and -1 is 3, and that's my d squared, which is 10. You might have noticed that I added those a little weird. If I go one way, I get a positive 1, the other way I get a -1. And one way gives me a -3, the other way gives me a +3. It doesn't really matter again, because we're squaring it. I'm just looking at it and thinking of it as simple as possible. What's the value between the two of them? Going from -1 to 0, it's 1. Going from -1 to 2, it's 3. Doesn't matter which direction you have to go. The point is that that's the distance from those two sort of one-dimensional points. Anyway, let's look at the next one. Well, the -1s doesn't change. X's don't change. And then my y's, well, between 2 and -1, again I have a 3 squared. So now my d squared is 9. For this next one, we have 4, 1. So the distance between -1 and 4, or the difference between -1 and 4, it's actually the same thing, is 5. So I square that and I add it with the other, which is 1 squared, and that gives me d squared, which is 26. And now for this last one. Well, to go from a 0 to a -1, you have to move 1 unit away. So I square that. To go from a 3 to a 2, you also have to move 1 unit away. So my d squared is 2. So which of these is smallest? Well, it's this one. Now, I could have done all of these in terms of finding d itself. If I tried finding d itself, I would get the square root of 10. I would get 3. I would get about 5. It would actually be the square root of 26. And here I would get the square root of 2. It's just making things more complicated. How do you know if 3 is greater than or less than the square root of 10? Or how do you know how 5 compares with the square root of 10? All of these things, it's harder to tell which one comes first on the number line, which one is bigger and which one is smaller. So in this case, it's easier just to use d squared.